All right, welcome to the screencast for objective number 9 of our stoichiometry unit. So in this objective, we're going to perform the 3 types of stoichiometric calculations. The most basic one of mole to mole, which is a 1-step problem, and then mole to mass to mole, which is a 2-step problem, and then mass to mass, which is a 3-step problem. The mass to mass one is by far the most useful and beneficial because we can weigh out mass in terms of grams. You cannot weigh out moles on a balance. So even though that problem takes the longest to do, that's the one that is the most beneficial and most commonly used. So our essential question, how are mole ratios, molar masses, and dimensional analysis used to perform stoichiometry problems? This puts together everything that we've done. This is an area of chemistry that deals with the quantitative relationships between reactants and products. Essentially, what we're trying to figure out is if I have this much reactant, how much product can I make? Most of the time, you don't have the perfect amounts that the chemical reaction calls for. And so you work with what you have, or if you're in industry, you want to make, as much of this product as possible, so you need to know how much reactant to order. You're not going to order more reactant than you need. That's a waste of money. Or you're not going to use more reactant than you need in that reaction because that would, again, be a waste of money. If you're trying to make X amount of product, how much reactant do you have to have? So there are 4 steps to all stoichiometric problems. The first one is you must have a correct balanced equation. And this is where everything you've learned up to this point comes into play at. Writing that equation, making sure it's balanced, making sure you have the correct formulas. Then you must determine the number of moles of your starting substance. If it's not in moles, like if it's in grams or atoms, you have to convert it to moles. Then you determine the mole ratio of the desired substance to the starting substance. So you're going to go from what you're starting with to what you're wanting to end with. And then you calculate the desired substance in the unit specified. It might be moles or grams, or it could be atoms, but most of the time you're going to see it as moles or grams. And like I said, that third step in a mass-to-mass problem, going to grams is way more useful because that's what I know I can actually weigh out on a scale. So here's kind of the steps, the 3 steps to stoichiometry problems for the 3 types. If you are dealing with a mole-to-mole problem, meaning I'm starting with moles of one substance and I want to know how many moles of another substance I need. I can just do that in a 1-step conversion using the mole ratio. That's the nice part about using a mole ratio in the equation. It's just the conversion factor. If I'm doing a mass to mole problem, I have to first take the mass of A and convert it to moles of A. Then I can do the moles of A to moles of B, just like up here in a mole to mole problem. If it ends up being a mole to mass problem, I start with moles of A, and then I can calculate, or then I can use the mole ratio to go to moles of B, but in this particular problem, it wants mass of B. So both of these I convert using the mole ratio, and then the molar mass of either A or B, not both of them. The last one, again, the most useful one, mass to mass, is where I go from mass of A, so I start with gram amounts of A, and then I convert that to moles of A, convert it using the mole ratio to moles of B, and then convert that using the molar mass to mass of B. So by using the mole ratio with the molar mass of A and the molar mass of B, I can do this simple 3-step problem. So what I've done is I have included these videos in here. You need to watch these video clips. This is a person going through explaining how to solve a mole to mole problem, a mole to mass problem, a mass to mole problem, and a mass to mass problem. So you need to watch all 4 of those. I have linked them here in the PowerPoint. They are also on the screencast sheet, all 4 of them in this order. So you can access it either way. And then the next slides are just some practice problems. So the first set is mole to mole, where I say I'm starting with moles of hydrogen and I want to know how many moles of ammonia I can make. And I was nice and gave you a balanced equation. And so these 2 problems are mole to mole. Go ahead and try them. We're going to do these in class. These are the practice problems that we will do in class. But go ahead and try them, and then that way we can compare what you are doing on paper, or what you're doing on your own, to what we're doing in class, and we'll see where some of your errors might be, or if you completely understand the concept. The second type of problem, mole to mass, mass to mole, In this one, I've started you out with a mass, and I've asked you to calculate the moles of a substance. So that is a mass to mole. The second one is also a mass to mole problem, where I give you a gram amount and I ask you to convert it into moles. This one right here is the mass to mass, these two practice problems. So I start you with grams, you're going to end with grams. So there's 6 practice problems, and we'll probably do a few more if needed. And I will definitely make sure and do a mole to mass one, mass and a mass to mole one, so that way you get an experience or exposure to both of them in class. So we will do practice problems in class, and then you will be turned loose to do more practice problems. So the summary for objective number 9 is a 3-2-1 format, and you should be able to complete this, especially watching those 4 YouTube videos that are present in this screencast.